In today's society, there are new generation of concepts, peoples, and ways on how mathematics can be taught in nurturing one's mind and numerical ability. There are people who have a huge contribution in developing a more effective way of teaching and providing those evolved concepts in relation to set theory. Hello there, Actionmates! Here we are today for a logical edition of our documentary, The Enigma Unveiled, Kurt Godel's Legacy in Mathematical Logic.
For today's edition, we are going to feature one of the biggest names in the field of logic, Kurt Godel. Kurt Godel is an Austrian-American born mathematician who discovered the idea of limitations of mathematical proofs, which directly affects one's views about mathematics. He also helps in order to point out how the truth can be proved.
As BS Mathematics students, it is highly significant that we are educated about how everything was proven and what are the things considered in finding logical truth in an axiomatic manner.
In addition, aside from Godel's existence and importance, let us first dig into the definition of set theory. Set theory is a branch of mathematics that deals with the mathematical theory of sets, collections, and collecting governed by axioms. Therefore, the idea of Godel brought us to a more specific definition of truth, accuracy in finding answers, solving mathematical problems, and especially in proving a certain mathematical proof. For deeper understanding, let us know the most notable contribution of the enigma.
Godel's completeness and incompleteness theorems are fundamental principles in mathematics that have profound implications, particularly in the realm of set theory and a very core of mathematical reasoning. They act as a guiding lights in illuminating an essential aspect of mathematical landscape.
These theorems clearly emphasize the relationship between formal systems such as set theory, in which it can prove statements and obtain an accurate conclusion.
Completeness theorem. Completeness theorem is a concept of mathematics that deals with the formal way of proving within a certain framework if there is something true within a specific mathematical framework.
It is important because it gives a clear connection between the structure of mathematical statements and their actual truth.
If we apply the theorem in set theory, as an example, if we have a true statements about sets, like the union of two sets is a set, Godel's theorem guarantees there's a formal proof for it within the mathematical system you're using. The same idea applies to other areas of math, ensuring that if something is true, there's a way to prove it formally in the mathematical system being used. This shows the link between the formal rules of math and the truth of mathematical statements as long as the system is consistent.
Aside from completeness theorem of the logical enigma, there is another theorem which also highlighted to its name, the incompleteness theorem. But there are two of them, the first and the second incompleteness theorem. What are these? Let us talk about it.
The first incompleteness theorem is all about the limitations of formal math systems. It says that in systems like set theory, there are statements we can prove to be true or false using the rules of that system. For example, consider the statement, there exists an uncountable set of real numbers. This is a true statement because real numbers are uncountable. But Godel's theorem tells us that within the rules of set theory, you can prove if this statement is true or false. In essence, this theorem shows that there are boundaries to what formal math systems can prove, revealing their inherent incompleteness for certain statements.
But the second type of this theorem pointed out that formal systems like set theory, ZFC, can prove their own consistency using their own rules. This means even in set theory, you can use its rules to show it's free from mistakes. For example, it's like having a rule book for playing with sets, but you can't use the rules in that book to prove the rule book has no errors. You'd need an external source to confirm the rule book's correctness. These make us question how reliable set theory is by itself.
From that discussion, we learned that Godel's theorems are truly significant in stating proofs, and it clearly specifies every detail of logic, which leads us for a clear understanding and conclusions. It also shows us correctness, despite more technicalities in the field of logic.
Kurt Gödel's remarkable contribution to the set theory not only strengthened its foundation, also paved the path for extensive exploration and development in the field. His famous contribution, Incompleteness Theorem, Gödel's idea have an ongoing influence and serve as a source of inspiration for research in this field. Established his contribution as deeply respected and acknowledged.
Godel's work made a huge and lasting impact on the world of set theory and the philosophy of mathematics. His famous work, Incompleteness Theory, continues to be studied and analyzed by mathematics to this day. Knowing and understanding his work helps individuals gain insights into the boundaries, limitation, and fundamental inquiries about mathematics and logic. It also provides a deeper understanding of the history and development of mathematics and logic that would definitely be valuable for everyone, especially people who are related to this field.
Theories expanded the boundaries of human understanding, reminding us that even with the vast universe of set, there are truths that elude from formal proofs, enriching the very essence of mathematical theory.
With this, our thoughts can be valid and can obtain an accurate and precise conclusion which can affect certain circumstances even if it is mathematically related or not.
Kurt Godel has contributed one of the most important concepts in the field of mathematics in the terms of proving a structure of logic.
That's why he hailed as one of the greatest mathematicians of all time and one of the pillars of logic, the one and only enigma with an axiomatic and invincible legacy, our math hero, Kurt Godel.